Hi guys, a very good evening everyone. Welcome to the session. Welcome once again to the question series from the very good and the famous book for signal and system, that is the Oppenheim and Wilsky. And chapter by chapter, as I promised, we are discussing the questions, important questions out of that, those which can definitely be related with the gate level. Okay, and you know, from signal and system, sometimes the good questions also coming up in the gate exam. So all that good variety will be covered. If you have followed the last three classes, so 3 chapters we have completed, you must have got to know that how really good questions can be framed from this particular subject, that is the signals and systems. Yes, very good evening all. Good evening Ashok. Good evening Harihar. So chalo, come on, let everybody join quickly. Okay. Okay, chalo. So all ready, I think. Good evening Bhanu. Chalo. So me also ready now. So today the chapter number 4 of Oppenheim, and that is about the very important chapter, Fourier transform. Okay, continuous time Fourier transform. Next class we will see the discrete time Fourier transform also, that will be the DTFT. वो भी देखेंगे next class में. Okay, चलो. Yes, Ashok, I'll have the HPCL syllabus discussion definitely, but the site is not opening. In case if you have the syllabus by chance, I'll request you to share me on Telegram, because I've been tracking the website, okay, you know, since afternoon, okay, but it's not opening up, I think. Okay, it's not opening up. So if you have the, you know, latest syllabus, please do share me in the Telegram, then we can have the discussion and the complete planning around it. Okay, tomorrow morning itself we can discuss that live. Okay, so if any of you have that, you know, discussion, the syllabus for EC as well as EE, please do share with them, EE especially. Okay, chalo, share me in the Telegram. Chalte. So there's a regular introduction about me, that's all. Okay, so guys, like all other classes, you will get the today's class PDF, okay, in my Telegram group with the complete solutions, complete questions, A to Z points that we discussed, and also for daily important questions and doubt discussions and updates about examination, multiple things. You know, you can be connected in the Telegram group. I'll share you the link also directly in some time. Okay guys, so on the BYJU'S exam prep tomorrow, that is Wednesday, okay, at 7:30 p.m. okay, all your favorite Dheeraj Sardana sir is coming live to talk on an important area, GATE 2025. What is the right time to prepare and how to prepare for GATE 2025? Okay, this Wednesday, that is just tomorrow at 7:30 p.m. Also guys, the national scholarship test for BYJU'S, you know, from BYJU'S exam prep, okay, it's going to be there on the 15th of October. Sorry, that's going to be 22nd of October. That's going to be on the 22nd of October. Okay, it will start at 9 a.m. So if you want to take a next step towards success in GATE and want to enroll for the complete courses of BYJU'S exam prep, you can appear in this scholarship test, and based on your performance, you can get as much as up to 90% scholarship on the GATE preparation programs. So guys, chalo, let's get started. The first one, 4.21. Okay, the 4.21. Compute the Fourier transform of each of the following signals. Compute the Fourier transform for each of the following signal. The first one, okay, एक एक करके discuss करेंगे. So we have the first one, e power minus at cos omega naught t into ut. Now try to think, okay, which of the, see, there are some Fourier transform pair which compulsorily student has to remember. Okay, not everything you can derive in the exam. Okay, so there are some Fourier transform which you must compulsorily remember. Okay, so we will keep using it. Like in the first case, e power minus at ut can be directly used. E power minus at can be directly used. So let us start the first one. Okay, in the first one, the signal that is given to you is e power minus at cos omega naught t into ut. Okay, now a small modulation theorem along with the basic property. Okay, what you can write it as, e power minus at ut, let's take e power minus at ut multiplied by cos omega naught t, multiplied by cos omega naught t. So dear, for e power minus at ut, what is the Fourier transform? that is given by 1 upon a plus j omega only for positive values of a, and I think yeah, that is specified only for positive value of a. Okay, correct. So 1 upon a plus j omega. Now when any signal is multiplied here, direct convolution property, modulation property, sorry. Okay, when any signal is multiplied by cos omega naught t, its spectrum is shifted to what? Its spectrum is shifted to, so suppose dear, you have a gt signal having the Fourier transform g omega. Okay, so when gt is multiplied by cos omega naught t, what is its Fourier transform? Its Fourier transform is given by g of omega plus omega naught shifted to higher frequencies. Okay, centered at plus minus omega naught. So g omega plus omega naught plus g omega minus omega naught is whole divided by the 2. That is whole divided by the 2. Okay, so similarly here you can directly write down the result using what? Using the modulation property. This is nothing but the modulation property, correct? So it will become 1 upon, okay, पहले तो 1 by 2 separate कर देते हैं, 1 by 2, then 1 upon a plus j omega plus omega naught once. Okay, plus 1 upon a plus j omega minus omega naught. Okay, that is what modulation is. That is what modulation is. Okay, ठीक है जी, done है. Next, so this is the answer, that's it. The answer is in front of you. The answer is in front of you. 1 by 2, 1 upon a plus j omega plus omega naught plus 1 upon 1 plus j omega minus omega naught. That's it. Okay, if you don't remember modulation, you can solve it by the frequency shift property by, you know, expanding the cos as e power j omega naught t plus e power minus j omega naught t whole divided by 2. Okay, next question, little bit similar, e power minus 3 mod t sine 2t. E power minus 3 mod t sine 2t. Okay, coming to the part B. Okay, the signal xt is given to you as e raised to the power minus 3 mod t into sine 2t, right? So dear, what is the Fourier transform? So everything that you have to recall, let me keep writing here. E power minus a mod t Fourier transform is given by, okay, 2a upon a square plus omega square. Okay, again defined only for positive values of a. Okay, so let's use this. Okay, so e raised to the power minus 3 mod t. So yes, a is equal to 3, positive hai. Okay, that will have the Fourier transform 2a, that is 2 into 3 is divided by a square plus omega square. So this is directly 6 upon 9 plus omega square. Now this is multiplied by sine 2t. Now dear, again similar to modulation, see modulation we only define multiplication with cos. Okay, but if you want to write down what is the Fourier transform of any signal gt when multiplied by sine omega naught t, let me generalize it, sine omega naught t, so it should be given by what? Sine omega naught e power j omega naught t. Okay, सबसे पहले e power j omega naught t, that will give the frequency shifting term g omega minus omega naught minus e power minus j omega naught t. तो g of omega plus omega naught frequency shift में sign opposite चलता है divided by 2j. So you can remember it similar to modulation. Okay, similar to modulation theorem, correct? Okay, so यहाँ पे, okay, so signal is e raised to the power minus 3 mod t multiplied by sine 2t. Okay, will have the Fourier transform 6. Okay, देखो 1 upon 2j separate, then you have 6 upon 9 plus first omega minus omega naught. Okay, so omega minus omega naught, what should be the value of omega naught? That is equal to 2. So omega minus 2 whole square minus again 6 upon 9 plus omega naught, that is omega plus 2 ka whole square. Okay, so this is gonna be final answer 6 by 2j. Okay, we can write it as minus 3j. Okay, yeah, if you want you can leave it in the form of 3 by j, whatever it is. 1 upon j minus j bhi likh sakte hain. 1 upon 9 plus omega minus 2 whole square. Okay, minus 1 upon 9 plus omega plus 2 whole square. That's it, done. Correct है, yeah, correct Ananta, correct approach. ठीक है जी. So some fundamental but yet expected gate questions are. Now part number C, चलो इस पे focus करते हैं. Part number C, 1 plus cos pi t. Okay, for mod t less than equal to 1. Here you should learn, okay, something good property. पार्ट नंबर सी पे आते हैं। पार्ट नंबर सी में बोला है सिग्नल xt इज गिवन बाय 1 प्लस कॉस पाई टी रेज्ड कोसाइन पल्स, ओके, फॉर mod t less than equal to 1, that is -1 less than equal to t less than equal to 1, that is what mod t less than 1 मतलब t is -1 to 1, otherwise it is 0. So that is the only signal given. Okay, that is the only signal given. Yes, yes, Ashok, definitely. And if you watch the previous classes also, I'm sure you will get good concept clarity, you know, in the Fourier series, LTI system, all the previous classes if you follow. हाँ, so आ जाते हैं यहाँ पे. So xt is given to you 1 plus cos pi t into is only multiplied by you know, when the t is between -1 to 1. So how about this particular waveform, dear? How about this particular waveform? इसको थोड़ा सा समझ लेते हैं. How about this particular waveform? Okay, now let us try to sketch this particular waveform. Let us try to sketch this waveform. So it is only defined from -1 to 1. Okay, so if you take t 0, okay, cos 0 is 1, so 1 plus 1 will be 2. Okay, it's nothing but it's a raised cosine pulse. If you know cos pi t, तो 1 plus cos pi t, amplitude को raise करना है, raised cosine pulse बोलते हैं इसे हम. Okay, now, okay, t is -1, okay, या t is 1, तो cos pi या cos minus pi, cos pi या cos minus pi both are equal to -1, तो 1 minus 1 0 हो जाएगा. Okay, 1 minus 1 will be 0, so just there will be a cosine pulse of this nature. Okay, only half period of it will come, -1 से 1. Okay, -1 से 1, that's what it is. Between the -1 to 1, कुछ ऐसा हो जाना चाहिए. Am I correct? So 1 plus cos pi t. Okay, at t equal to 0, cos 0 will be equal to 1. Okay, cos 0 will be 1, so 1 plus 1, it's going to be 2. Okay, it's going to be 2. Okay, now t between -1 to 1. एक बार रीचेक कर लेते हैं. At t equal to, that will be 1 by 2. नहीं, हाँ, at t equal to 1 by 2. हाँ, ठीक है, perfect. ठीक है. Now, okay, now last class में बोला ना, power signals are like what, Ananta? Okay, like periodic signal. What is the Fourier transform of periodic signal? Okay, that impulse method, it will always contain equidistant impulses located at harmonic frequency of the signal. Okay, I think we discussed that in the Fourier series class. So this is the xt. Now how can you write down xt? The way to define xt is 1 plus cos pi t. Okay, but if I only write down 1 plus cos pi t, it is an incomplete definition. If I only write down 1 plus cos pi t, it's an incomplete definition. What you can do is, how you can imagine this signal is, okay, how you can imagine this signal is, okay, suppose you want to take the entire cosine pulse. Suppose you want to take the entire cosine pulse. Okay, ये शेप यहाँ पे वापस कुछ इस तरीके से लेगा, don't mind the exact shape, but if you want to take the exact cosine pulse, okay, exact cosine pulse, okay, that is from -infinity to infinity, okay, but it is only restricted from -1 to 1. So now apply a window here. Okay, apply a window here. Okay, that is from the -1 to 1. -1 to 1, let me apply a window. Okay, whose amplitude is 1. Okay, apply a window whose amplitude is 1. That means if you multiply this complete 1 plus cos pi t waveform, if you multiply it with rect function, not the step, rect function actually, Shubha, if you multiply it with rect, okay, that rect should be from -1 to 1 and it should have the amplitude 1 so that it doesn't change the amplitude of this function. You will get back the above waveform. So this can be written as 1 plus cos pi t is multiplied by rect by, what is the width of the rect? Required 2, so rect of t by 2. Okay, rect of t by 2. Okay, so now here comes an important formula. I'm telling you, some formulas like e power minus at ut, e power minus a mod t. Next one, rect t by t. Everybody should remember. Everybody should remember. Okay. So देखो xt, if I first open the bracket, it is rect of t by 2. Okay, plus rect of t by 2 is multiplied by cos pi t. Now the formula that everybody must remember is this one. Okay, let me highlight it here separately, and that a very important formula, rect of t by t. What is the Fourier transform rect of t by t? It is given in the form of sampling function, t sampling omega t by 2. Yeah, if you want you can write it in the sinc function also. Okay, t, okay, sampling omega t by 2, t sampling omega t by 2. Clear everybody? Okay, acha, the dual of this, what is the Fourier transform of sampling at? That will also come in the upcoming question. What is the Fourier transform of sampling? It will be rect, and it is given by the formula pi by a rect of omega by 2a. When I say rect t by t, there is a rectangle whose total width is t, minus t by 2 say t by 2. So here the total width required is 2, so I have written rect of t by 2. Okay, now everybody can solve. Okay, now you can solve up. What is the answer? X omega. Okay, what is the answer? X omega, rect t by t. Okay, 2 sampling omega t by 2. Okay, t sampling omega t by 2. Okay, plus again, now what is this? If you know for rect t by 2, okay, rect t by 2 multiplied by cos pi t, again modulation will apply. Okay, तो ये part कितना हो गया? Okay, this part is actually 2 sampling omega. Okay, 2 से 2 cancel किया, तो 2 sampling, okay, omega. Now modulation if you apply, okay, half, okay, ये कितना हुआ? पहले इसको पूरा लिख लेते हैं, 2 sampling omega, तो यहाँ पे आ जाएगा 2 sampling omega, okay, minus omega naught, that is omega minus pi plus, okay, omega plus omega naught, to omega plus pi. Okay, so my answer is in the last two terms sampling cancelled. Okay, so it will be, sorry, 2 से 2 cancel, so sampling omega minus pi plus sampling omega plus pi. 2 sampling omega plus sampling omega minus pi plus sampling omega plus pi. This should be the answer. Okay, again apply the modulation property. Or yes, Shubha, you can also tell by frequency shifting. Modulation comes from frequency shift property only. Okay, that is the Fourier transform. Part number C, dear, that is the Fourier transform. Clear, everybody? Now you have to look into the options. Okay, how the options are given, whether the options are in the form of sampling function or whether they are in the form of sin theta by theta. Okay, whether they are in the form of sin theta by theta. So when I use sampling x, okay, it is given by sin x upon x. If I am using sampling x, that is given by sin x by x. Okay, chalo, so C part done. Okay, but through a good property, rather than integrating it through a good property, this has been done. Okay, part number D. This is simple actually. Okay, part number D is simple. Summation 0 to infinity. Okay, AK delta t minus kt. Okay, आ जाते हैं part number D पे. xt is given by summation k equal to 0 से infinity alpha power k delta t minus, okay, delta t minus kt mod k less than 1. Mod alpha less than 1. Okay, so now expand with all values of k. So what is the signal xt? Okay, first is alpha power 0, that is 1 into delta t. What is the next term? Alpha power 1 delta t minus t. What is the next term? Alpha power 2 delta t minus 2t, etc. till infinity, right? Okay, so what is the Fourier transform? Fourier transform of impulse is 1. Okay, alpha delta t minus t, delta t Fourier transform 1, time shifting property. There will be exponential phase term in the frequency domain, so e power minus j omega t. Next हो गया alpha square. Okay, 1 into e power, now time shifting by 2t, so e power minus j omega 2t. Okay, plus etc. So this is nothing but 1 plus, if I combine, alpha e power minus j omega t. Next term is alpha square e power minus j omega 2t. So this can be written as alpha e power minus j omega t and then whole square. Similarly, if you write down the next term, that will be alpha e power minus j omega t but whole cube till infinity. Okay, so what should be the answer? It's a clear GP case. Okay, with the first term 1 and 1 minus common ratio, that is 1 minus alpha e power minus j omega t. That's the answer. Okay? Yes, infinite GP we get. Correct, it's like impulse train only, Ananta. So that is the answer. 1 upon, acha, why the GP will converge? Because mod of the common ratio, okay, mod of the common ratio, okay, the mod of R, okay, common ratio is alpha e power minus j omega t. First of all, R e power j theta, magnitude is R. Okay, so magnitude means only mod alpha, e power j theta ka magnitude 1 hota hai. Okay, and mod alpha less than 1. It is given mod alpha less than 1, so GP converges. GP will converge. Okay, so that is the value of x omega. Done. So D part is done. Let's come to the E part, guys. E part is similar. Okay, so I'll give you this as homework. E part is homework because again it is multiplication with sin 2t. It is a multiplication with sin 2t. Only thing is t e power minus 2t ut. t e power minus at ut, that must be known to you. Okay, I telling you na, basic formula should be known to you. So t e power minus at ut, let's revise that, 1 upon a plus j omega whole square for positive value of a. Done hai? This formula definitely must be known to you. Okay, 1 upon a plus j omega whole square. Okay, yeah, that comes from frequency differentiation, but it's an important signal t e power minus at ananta. So remember the formula, 1 upon a plus j omega whole square. Now next is again frequency shifting or modulation. Okay, that you can apply. Okay, that you can apply. Okay, chalo, so E will be a homework to you. Okay, now F. Okay, let's come to F. Okay, that's going to be a little bit interesting. So aa jate hain F signal pe. Okay, what's going to be the F signal? Okay, E is the homework for you. Okay, तो जो similar repeated होंगे उसको homework करेंगे because many questions to discuss. Okay, so F sin pi t by pi t and sin 2 pi t minus 1 upon pi t minus 1. Sin 2 pi t minus 1 is divided by pi t minus 1. Let me check it out once again. Perfect. Perfect. ठीक है, अब आ जाते हैं. Okay, let's solve it here. Okay, so first of all, okay, I can arrange this as sampling pi t upon sin pi t upon pi t. Okay, that is sampling pi t. Sinc t भी बोल सकते हैं उसको. Okay, और sampling pi t. ठीक है. Now sin 2 pi t minus 1, इसको देखो थोड़ा सा रीअरेंज करेंगे. Multiply and divide by 2. So if you multiply by 2, denominator में 2 आ जाएगा. Correct? Okay, now this becomes sin theta by theta. That is again sampling function. So sampling of what? Sampling of क्या आया यहाँ पे? Sampling theta by sin theta by theta. Sampling theta. So theta is 2 pi into t minus 1. Okay. So there is multiplication in time that corresponds to convolution in frequency. Correct, Shubha? You are able to come to the property. Correct. So that is what it is. Okay. So sampling pi t into 2 sampling pi 2t minus 1. Now how to deal with that? Okay, how to deal with that? So let me write down this one a little bit clearly. 2 sampling pi t is multiplied by sampling 2 pi t minus 1. Okay, now what is the Fourier transform for sampling pi t? I already revised this na. मैंने बोला था ये आएगा. Rect, sampling, triangle, all these are very very important here. I told you this will come up. Okay, so sampling at pi by a rect omega by 2a. Sampling pi t pi by a का वैल्यू पाई है, रेक्ट ऑफ ओमेगा बाई 2a, सो ओमेगा बाई 2 पाई. ठीक है. देन नेक्स्ट इज व्हाट? सैम्पलिंग 2 पाई t माइनस 1. ओके, दैट शुड हैव. अच्छा, पहले t माइनस 1 बाद में लाते हैं ना. लेट अस टॉक अबाउट सैम्पलिंग 2 पाई t. ओके, दैट इज गिवन बाय पाई बाई a, पाई अपॉन 2 पाई. ओके, rect of omega upon 2a. Okay, so 2a will become 4 pi there. ठीक है. So what is this? Pi से pi cancel करके directly you can write down rect of omega by 2 pi. Okay, and next one is 1 upon 2 rect of omega by 4 pi. Now that is only sampling 2 pi t. Okay, that is only sampling 2 pi t. So if you want to write down for sampling 2 pi and then t minus 1, okay, time shifting भी apply कर दें. So that will be 1 by 2 rect omega by 4 pi e power, okay, t equal to 1 की shifting है तो e power minus j omega, e power minus j omega. ठीक है. So there are the options coming up, whether it is going to be triangle or trapezoid. Whether it's going to be triangle or trapezoid, have a look into this. Okay, so now let's move ahead. Okay, so I have xt, which is 2 sampling pi t multiplied by sampling 2 pi t minus 1. So what is going to be its Fourier transform? Now two signals are multiplied in time. Okay, so they are convoluted in frequency. Okay, they are convoluted in what? They are convoluted in the frequency. Okay, so what are the frequency functions? You get 2. The convolution property is 1 upon 2 pi x omega convolution y omega. तो 1 upon 2 pi, okay, पहले का है rect omega by 2i. Okay, first is rect of omega by 4 pi. sorry, omega by 2 pi. First one is omega by 2 pi convolution with rect omega by 4 pi e raised to the power minus j omega. Okay. So now rect convolution rect can be triangle, can be trapezium. Okay, this is a phase term that's not going to affect your results. Okay, because ultimately that is coming from time shift. Okay, so that's not going to affect your results of the convolution of rect with rect. Okay, because ultimately both of them have the equal magnitudes. Okay, both of them just have the equal, both of them have the magnitude को convolute कर लेंगे. Phase can be additional, phase को separate रखते हैं. Okay, so now if I draw these two rectangles, dear, if I draw these two rectangles, so see what is going to be result. The first one is omega upon 2 pi. Okay, rectangle total base is 2 pi. Total base is 2 pi. Total base 2 pi means minus pi se pi can be written. Okay, amplitude 1. Next, omega upon 4 pi, that means total base is 4 pi, and if the total base is 4 pi, it can be extended from where? Minus of 2 pi se leke plus of 2 pi, amplitude 1. Amplitude equal to the 1. So they are of different duration, so definitely result will be trapezium. Okay, result will be trapezium. What is the result? I will actually draw it out in front of you. I'll actually draw it out in front of you. Okay, so what I'm actually doing, I'm drawing the mod of x omega versus omega. Okay, then later on we will multiply with the phase term. Okay, so I'm drawing the mod of x omega. So ये कितना होगा? Rect convolution rect. Okay, of unequal duration will give you trapezium. Minus pi minus 2 pi, the trapezium will start from the minus 3 pi. Okay, the trapezium will start from the minus 3 pi. Okay, then we have the minus 2 pi plus pi, the minus pi. Up to the minus pi, it will be a straight line. Okay, then from minus pi to plus pi, it will be a flat line, that is constant value. From pi plus 2 pi, last value will be 3 pi. So up to the 3 pi, it will then be a decreasing line. It will then be a decreasing line. ठीक है, ये हो गया. Right, so minus 3 pi se minus pi. What is the slope actually? The slope actually will be product of these two amplitudes 1 and 1, and outside there is also 1 by pi multiplied actually na, ये 2 hai. So 1 into 1 is 1, so this is 1 upon pi. The slope will be 1 upon pi. Okay, slope will be 1 upon pi. अच्छा, अब देखो height upon base, okay, is slope. Okay, 1 upon pi, that is equal to height divided by base, that is 2 pi. So height होना चाहिए 2. Height should be equal to 2. So this should be equal to 2. Perfect. Okay, this should be 2. And then this is going to be a decreasing line, slope minus 1 by pi. Okay, this is the mod of x omega. So what is the final answer? Okay, in the expression, if you want to write down, the final answer will be x omega will be modulus of x omega e power minus j omega. Okay, e power minus j omega. With respect to get this graphical result is more important rather than writing the expression. Telling you now, rather, of course, we pick up the questions from OpenHAM. They are very good. Okay, but we'll try to answer in a way in which more and more gate knowledge and gate type of pattern is matched. Gate type of pattern is matched. Okay? Chalo. So this one was a good question. Okay, now how rect convolution rect is trapezium. Okay, that again must be known to you. If not, you can watch. I have made, I think, a separate video on this convolution of two rect. Okay, it can be triangle or trapezium. Okay, how to find the parameter of trapezium, what is the slope, where does it start, what is this point, etc. Everything you can find in those videos. Okay, right now let's go to the next question. This was the F part done. Okay, so we are done up to the F part. Now G, which is xt as shown in the figure 4.21a. This is the A figure. Okay, and I need to find this. So, okay, there is a constant and there is a straight line, then again a constant. The simple way to differentiate, simple way to solve it, guys, try to differentiate it once. Try to differentiate this once. Okay, try to differentiate this one. So when you try to differentiate, what you are going to get? Okay, when you are trying to differentiate this, yahi karte hain, okay. Let us differentiate this here. Okay, let us take the derivative d by dt. Let us take its derivative d by dt. So if you take its derivative d by dt, what you are going to get, I shall show you here. I shall show you here. Okay, so देखो -2 से -1 it's a constant. Okay, what is the differentiation of constant? Of course it is 0, but at -2 there is a discontinuity. At -2 there is a discontinuity, and whenever there is a discontinuity at any point, there will be impulse located at that point. There will be impulse located at that point, and since there is a fall discontinuity here, so there will be a negative going impulse. Okay, the difference is -1, so negative going impulse with the area -1. Okay, with the area -1. So at -2, first of all you should be having an impulse, okay, with the area -1. Okay, then similarly again, if I come to this portion, 1 से 2 flat constant का differentiation 0, but again at t equal to 2 you see there is a fall in the value. There is a fall discontinuity, so there will be another impulse at t equal to 2 of same area. There is another impulse. Okay, next between the -1 से 1, okay, you will understand why I am differentiating it. Ananta, dekhna, between the -1 to 1 it's a straight line, okay, passing through origin. It's a straight line passing through origin. Okay, so that is given by y equal to mx plus c. Okay, so y becomes how much? Okay, slope कितना हुआ? Height upon base 1. So slope is 1 and passing through origin, so c is 0. So it is like y equal to x. When you differentiate y equal to x, what is dy by dx? 1. Okay, so between -1 to 1, okay, between -1 to 1 you will get the answer of the derivative as 1. The answer of the derivative as 1. This is the graph for x dash t. This is the graph for x dash t. This is the graph for x dash t. Okay, done. Now, if you look into the graph of x dash t, it contains impulses, it contains rectangular functions, and I know that you know the formulas. Okay, so now this can be easily dealt with. Okay, so what is x dash t? Coming to the part number, this is called G, right? Coming to the part number G. Okay, so part number G, I am starting with x dash t, and that contains first of all a rectangle. Okay, from -1 से 1. So total width of the rectangle is 2. Okay, total width of the rectangle is 2. Okay, right? Okay. For a triangular, see, if it is a triangle centered at origin, so Bashri, if it is this regular triangle, then you can remember the Fourier. But if it is any random triangle or something like that, then you can differentiate and solve it up. Okay, but if it is a symmetric triangle, try t by t. So better to remember because its Fourier transform is sampling square. Again, an important case that is. Okay, so you get rect of t by 2. Okay, not only rect of t by 2, वापस आते हैं. So this portion is rect t by 2, total width is 2. But also there are two impulses. Okay, one at +2, one as -2. Both are having the area -1. So I will write down minus को common ले ले. One is at t equal to -2, so delta t plus 2. Another one is at t equal to 2, so delta t minus 2 will be written. Now what is the Fourier transform? By the way, what is the Fourier transform for x dash t? The Fourier transform for x dash t is j omega x omega. Fourier transform for rect t by 2, 2 sampling omega. अभी लिखा था ना, t sampling omega t by 2, so that is 2 sampling omega minus Fourier transform of delta t plus 2. Delta t Fourier transform is 1. Okay, t plus 2 time shifting e power j2 omega. Delta t Fourier transform again 1 time shifting delta t minus 2 e power minus j2 omega. ये हो गया, ठीक है. So what is the value of x omega? Your answer is almost obtained. The x omega will be, okay, 2, ये कितना हो गया, चलो इसको कंप्लीट कर लेते हैं. तो दिस पार्ट इज 2 सैम्पलिंग ओमेगा माइनस व्हाट इज दिस e पावर j थीटा प्लस e पावर माइनस j थीटा. ओके, दैट इज 2 cos थीटा. दैट इज 2 cos थीटा. थीटा का वैल्यू 2 ओमेगा है, बट दिस इज द वैल्यू फॉर j ओमेगा x ओमेगा. सो व्हाट इज द वैल्यू फॉर x ओमेगा? ओके, दैट कैन बी 2 को कॉमन लिया, 2 बाय j ओमेगा, okay, into the sampling omega minus cos 2 omega. Again you have to check how the options are given. Okay, maybe in the form of sampling or maybe in the form of sin omega by omega. Anything can be done. Okay, anything can be done. कौन सा फंडा impulse का? I mean impulse Fourier transform is 1 or what else you want to ask Ananta? Be little clear. ठीक है जी. So this is the G part answer. This is the G part answer. Okay, now H. Okay, xt is as shown in the figure. Xt is as shown in the figure. This is periodic signal again. This is periodic signal again. Okay, this is periodic signal again. Okay, what is the Fourier transform for periodic signal? Okay, what is the Fourier transform for periodic signal? आ जाते हैं H part पे. In the H part, dear, xt is a periodic signal. For any periodic signal, okay, what is the Fourier transform? What is the Fourier transform? Okay, that is given by 2 pi. Okay, it's a standard formula, 2 pi summation minus infinity to infinity ck. Okay, that is the Fourier series coefficient ck. Okay, ck delta omega minus k omega naught. Okay, 2 pi summation ck delta omega minus k omega naught. It only contains impulses. Okay, it only contains impulses located at the harmonic frequency of the signal. What is the area of impulse? That depends on Fourier series coefficient. What is the ck? Ck is your regular Fourier series coefficients. Okay, ck is your regular Fourier series coefficients. Acha, now how do you calculate the Fourier series coefficients? You have the shortcut. How do you calculate the Fourier series coefficient? 1 upon time period xp k omega naught. लास्ट क्लास में ये शॉर्टकट एक्सप्लेन किया था. आई एक्सप्लेन्ड द शॉर्टकट इन द लास्ट क्लास. ओके, व्हाट इज एक्सपी ओमेगा? एक्सपी ओमेगा मींस फोरियर ट्रांसफॉर्म ऑफ वन पीरियड. सो व्हाट इज दैट वन पीरियड? लेट अस कम टू दैट वेव फॉर्म. यहां पे आते हैं थोड़ा सा. व्हाट इज द वन पीरियड ऑफ दिस सिग्नल? ओके, हैव अ लुक इनटू दिस. देयर इज अ इंपल्स ऑफ एरिया 2. Okay, at origin. Again the same impulse repeats at 2. Again the same impulse repeats at 4. Okay, so first of all, what is the time period? Time period is 2. So what is the information in one time period? There are two impulses. One is of area 2, one is of area 1. Okay, this is what is known as the XPT. I call this as XPT, one time period of the signal. That is known as what? One time period of the signal. So what is there? XPT. यहाँ पे आ जाते हैं. So I know what is the XPT now. There is an impulse at origin at area 2, 2 delta t. Then there is another impulse which is at t equal to 1, delta t minus 1, right shifted. Delta t minus 1, that is the right shifted. 2 delta t plus delta t minus 1. Clear? ठीक है. चलो. Now what is xp omega? What is the Fourier transform? What is the Fourier transform? I asked you Ananta, please specify your doubt clearly. What is the doubt with impulse? Impulse का क्या समझ में नहीं आया? थोड़ा सा clear बताइए मेरे को. Okay, 2 delta t Fourier transform 1. Delta t minus 1, time shifting property e power minus j omega will come. So what is the xp omega? Xp omega is 2 plus e power minus j omega. Now I have to put xp k omega naught. What is the time period here? Time period as I've shown you is 2. So what is going to be omega naught? That is known as 2 pi upon t. So omega naught will be pi. So what will be my Fourier series coefficient? That is going to be 1 upon 2 xp. Okay, xp. Okay. That is the Fourier transform. You will put omega equal to k omega naught. Okay, omega equal to k omega naught. So 2 plus e power minus j, omega equal to k omega naught, and omega naught is pi. Omega naught is equal to pi. Okay. For any periodic signal, last class I taught you this one. Last class को देख सकते हैं सुवन. Okay, this shortcut for calculating Fourier series coefficient is applicable for every periodic signal. Okay, ठीक है. चलिए आते हैं अनंत. जस्ट होल्ड ऑन, आई विल कम बैक टू दैट. लेट मी कंप्लीट दिस क्वेश्चन. ओके, सो ये कितना हो गया ना? व्हाट इज 1 माइनस ई पावर माइनस जे के पाई सेवरल टाइम्स. ये तो लास्ट कई क्लासेस से बोलता हुआ आ रहा हूँ. दैट इज 2 प्लस ई पावर माइनस जे पाई इज -1. ई पावर माइनस जे पाई इज -1, तो -1 की पावर के हो गया. ओके, लेट मी राइट इट हियर क्लियरली. सी के इज ऑब्टेन्ड. सो गाइस बी रेडी, देयर कैन बी अ डायरेक्ट Fourier series coefficient question on this. Right, tell the Fourier series coefficients of the waveform in the question H. So answer is here 1 by 2. 2 plus minus 1 की power k. 2 plus minus 1 की power k. That means, अच्छा, now what we know, अगर k का वैल्यू मैंने even लिया, okay, तो -1 की power even will be +1. 2 plus 1 3. So it will be 3 by 2 if k is equal to even. But if I choose any odd value of k, -1 की power odd is negative, तो 2 minus 1 is 1, तो answer is 1 by 2. Answer will be 1 by 2. That is what is the value of the ck. That is what is the value of the ck. That is what is the value of ck. Done है, ये हो गया डन है, ये हो गया ck का वैल्यू 3/2 and 1/2. So what is the Fourier transform now? X omega, it is 2 pi summation for all values of k from minus infinity से infinity ck delta omega minus k omega naught का वैल्यू पाई है तो delta omega minus k pi. Okay, shall I sketch this one for you? Okay, इसको sketch कर देते हैं चलो, so you can understand this more clearly. What is how does the Fourier transform of a periodic signal looks like? How does the Fourier transform for a periodic signal looks like? Okay, so it will only contain impulses. अब देखना इन impulses को. Okay, so number one, suppose k equal to 0, तो delta omega. Okay, but k equal to 0, 0 will be counted in even. Okay, so 3/2 into 2 pi, तो ये 3 pi. Okay, so this will have the amplitude, this will have the area, that is 3 pi. Next, k को जैसे ही odd लिया. Okay, if you take k equal to 1, there will be an impulse delta omega minus pi, that is located at pi. Okay, but what is going to be its area? देखो ना, for k equal to what? ck is 1/2. 1/2 into 2 pi. 1/2 into 2 pi, that is going to be pi actually. Okay, so that is going to be pi. Okay, so this one, this is having the amplitude area pi and it is located at pi. Now next, ये repeat होता रहेगा. Okay, next. Okay, this is 2 pi, this is 3 pi. Etc, etc, etc. This is going to be the Fourier transform for the signal. This is going to be the Fourier transform of the periodic signal. But in general, always remember this point. For any periodic signal, Fourier transform is given by 2 pi summation of for all values of k, ck delta omega minus k omega naught. Okay. Okay, Vikram, we can plan that. We can plan that. ठीक है, चलिए. Now, this is it, done. ठीक है, चलो. Now next part. So we are done with the H part. Okay, I part is there. So Ananta, just listen to me quickly. You can watch my fundamentals classes, signal and system ki. You will learn there that whenever any signal, okay, has a discontinuity at a point. This is a discontinuity. The value suddenly falls. Left hand limit not equal to right hand limit. Whenever signal has a discontinuity at any point, and if you differentiate it, at that point, always an impulse will come in the derivative. Okay, what is the area of the impulse? It is equal to the difference. Okay, the difference of magnitude. Okay, so यहाँ पे 0 minus 1, it's a fall ना, तो -1. Okay, the net change is -1. Okay, so -1. Okay, similarly, if you come to this point, again there is a discontinuity. Function value suddenly changes. Whenever there is a discontinuity at a point, the derivative will always contain an impulse. Okay, the derivative will always contain an impulse. ठीक है जी, done है. चलो. Done. This part is done. Now I. Okay, very quickly. I में ज़्यादा effort नहीं करना है. I can be solved directly only. Okay, it is given by 1 minus t square, 0 less than t less than 1. Quickly, the I part. Okay, the I part xt is 1 minus t square, 0 less than t less than 1. 0 less than t less than 1. Okay, so what we can do is, okay, quickly x omega integral minus infinity to infinity xt e power minus j omega t dt. Okay, इसको quickly integration से ही solve कर लीजिए, better होगा. Okay, so that is going to be limit 0 से 1. That is going to be what? Limit 0 से 1. Okay, 1 minus t square e power minus j omega t dt. Okay, limit is simple. That is why you can solve by integration. Only limit 0 से 1. Okay, now you can break it up. E power minus j omega t dt. Okay, minus integral. ब्रेक कर दिया इंटीग्रल को, टी स्क्वायर ई पावर माइनस जे ओमेगा टी डी टी, द लिमिट इज 0 से 1. ओके, देखो फर्स्ट वाला तो सिंपल है. ओके, ओनली द सेकेंड वन यू हैव टू सॉल्व इंटीग्रेशन बाय पार्ट्स. ओनली द सेकेंड वन यू हैव टू सॉल्व इंटीग्रेशन बाय पार्ट्स. कैलकुलेशन आप कंप्लीट करेंगे. आई डोंट थिंक वी आर हियर टू डिस्कस कैलकुलेशन, वी आर हियर टू डिस्कस गुड वेराइटी ऑफ क्वेश्चन. तो दिस इज जस्ट कैलकुलेशन, यू कंप्लीट. ओके, यू कंप्लीट. आई हैव गिवन यू द हिंट, इसको ऐसे ही करना है, राइट? In which case, Vikram? In which of the case you are telling? Abrupt change होता है. Yes, abrupt change means impulse आएगा differentiation में. बिल्कुल सही अनंता. ठीक है, चलिए, this is done. Okay, the I part is done, and with the I part actually, the 4.21 completely, I think this question taught you several good points. Okay, so I think this question taught you several good points. Let's jump to the next. Let us jump to the next. Let us jump to the next. Okay, थोड़े कुछ पहले beautiful property वाले cases को समझते हैं. Okay, here it is, next one. Okay, the next one. Right, determine which, if any, of the real signals depicted in figure 4.24, I'll show you the figure 4.24. Okay, this is the figure 4.24. Okay, have Fourier transforms that satisfy each of the following condition. देखो बहुत बढ़िया question है ये. Okay, these are all very good questions. So one by one, let's discuss this. Okay, what is the first one? Okay, the real part of xj omega, yeah, I simply write it as x omega. Real part is 0. What does it mean? What does it mean? The real part of a function is 0. Okay, the real part of a function is 0 means what? Okay, see Vikram, hint is key. Whenever usually you have ramps, you have straight line, try to differentiate and then solve. Okay, like that particular question. Yes, so if the real part of a function is 0 means that function is pure imaginary. But real part है ही नहीं तो क्या बचेगा? Imaginary. So conclusion is x omega will be pure imaginary. The conclusion is x omega will be pure imaginary. And x omega is pure imaginary. What does it mean? Okay, the signal xt is real. Okay, the Fourier transform is pure imaginary if the signal xt is real and odd. Okay, so the signal xt, dear, should be real and odd. The signal xt should be real and odd. Okay, so now I'll give you the waveforms. There are 6 waveforms given. You have to identify which of the waveform, okay, will satisfy the property 1. Then we will go to property 2, etc, etc, etc. Okay, the signal should be real and odd. Okay, so a property based question. These are good properties. You have to identify what is the meaning real part 0. Okay, indirect way of asking the property. Okay, so which of the signal is odd? देखो, first वाला odd symmetric है. Right, no. Yeah, this is also D also odd symmetric. These two are even. So only A and D. Okay, only A and D. So waveform number A, waveform number D. Okay, similarly, if I go to the second part, okay, वहाँ पे बोला है imaginary part of the function should be 0. Now, if a function has no imaginary part, if the function has no imaginary part, means it is purely real this time. The function has no imaginary part, it is purely real. Okay, the Fourier transform is real when the signal is real and even. When the signal, so anyways, real signal होगा, ये clearly mentioned है. All of the signals will be real, okay, which are mentioned in the figure also. Okay, now the signal must be real and even. So you have to highlight a waveform which is even as well, which is even. Have a look into this and tell me the answer. Have a look into this and tell me the answer, what it should be. बता दीजिए इसका आंसर. तो even, so this is odd. Okay, even or odd symmetry means you need both the side waveform. Only one sided waveform neither can be even, neither can be odd. Okay, तो ये दोनों तो नहीं है, ये odd है. This one is even and this one is even. Symmetry about y-axis, left and right are identical, mirror image of each other. That is obtained in the last two, waveform E and waveform F. Okay, this is ABC, DEF. Okay, waveform E and waveform F. This is known as the waveform E and the waveform F. ठीक है, last two. Correct, correct Subhashri, correct Ananta, correct Sathi. बहुत बढ़िया. चलिए, next question. The next is, there exists a real alpha such that, this one is good question. There will exist a real alpha such that e power j alpha omega x omega is real. Okay, now we know when the Fourier transform is real like this, when the Fourier transform is real, what to take. Okay, but what is real? Not the x omega, e power j alpha omega x omega. Third part को यहाँ पे solve करते हैं. Let us take it here. Third part, okay, e raised to the power j alpha omega. Okay, e power j alpha omega x omega is real. Okay, if this is real. अब देखो, whose Fourier transform is this? Whose Fourier transform is this? Xt has the Fourier transform x omega. So now in the frequency domain you have an exponential phase term, and that comes because of the time shifting. So you have to apply the time shifting property and x of t plus alpha, because in the time shift the sign is similar. T plus alpha, then you get x omega e power j alpha omega. Now this is real. Okay, that Fourier transform is real, and that is possible if the time domain signal is real and even. The time domain signal should be real and even. Okay, so I can say that x of t plus alpha is real and even. X of t plus alpha should be real and even. Okay, what is alpha? Question में clearly बोला है, there exists a real alpha. If you are able to think any real value, okay, such that you left shift the signal, yeah, even right shift, alpha can be positive, negative. You shift the signal xt, okay, it should become even. Okay, so देखो, definitely option number E and F will still be there. Because alpha is any real value, take alpha 0. Okay, if you take alpha 0, okay, if you take alpha 0, okay, that is also correct, na? So xt is real and even. Xt is real and even, so option number E, option number F. I mean, waveform E, waveform F is still answer, like the previous question. Okay, but, like look into this option number A. Look into this option number A. If you left shift it by 1 unit, if you left shift this by 1 unit, chalo don't left shift this, let me shift the origin. Relative hai na, either left shift the waveform or right shift the origin, the imaginary axis. So let me right shift the imaginary axis. This is your new imaginary axis. Now tell me, is it even symmetric? Now tell me, is it the even symmetric? Perfect, na? Okay, the portion on the right, the portion on the left are just copy of each other, reflection of each other. So yes, okay, after shifting it, this becomes also, okay, the correct answer. So here you have to left shift the signal by 1. Left shift the signal by 1. तो अगर आपने alpha को 1 लिया, okay, then you will have option number A also. Okay, option number A also. X of t plus 1 will become even. Okay, option number A. Okay, now here, okay, shift this impulse yaar. Shift this impulse, left shift by 1. Okay, इसको 1 से left shift किया. Okay, then this comes at origin. It is at origin, neither to the right nor to the left. So it is even symmetry. Okay, by right may be 0. What happened? Right also will be 0. Yeah, once again, don't left shift the signal. Okay, let me shift the origin only. Let me shift the y-axis. This is the y-axis or here high impulse. So right and left are identical, nothing. And if there is something at origin, that is okay. Okay, so yeah, okay, that is also. So even by left shifting by 1, you will get B also. You will get B also. You don't have to tell me the value of alpha. To explain you, I am telling you alpha, but they are not asking alpha. They are just asking if there is some real alpha which will make this condition true. So EFAB, ye to hai. Next. Okay, next. Okay, so that one was periodic. Okay, so periodic odd symmetric signal, by shifting it becomes even. This is purely odd. It is not periodic. Isko kitna bhi shift kar lo, it cannot show even characters. Okay, this is not correct. What about this one? Is there the possibility to do with the C option as well? Okay, this waveform. देखो ध्यान से देना, yes, you can try to make it, but listen to me, it is starting from 2 and going up to the 8. So what is the midpoint? Okay, 2 plus 8 divided by 2, midpoint होगा 5. Okay, इसका midpoint होगा 5. Okay, so I have 2, 3, okay, here are 2, here are 3, here are 4, here are 5. Okay, so if I try to take it about the center point, okay, then it will be odd symmetric, but even नहीं हो सकता. Okay, नहीं, sinusoidal even नहीं होगा विक्रम. Why? Because look into the range. It depends on the range. It is going from 2 to 8, so midpoint is 5. Okay. Acha, why I am separating about the midpoint? ये भी बता देता हूँ. First, you see about the midpoint, that is 5. Okay, it is like it's like a sine wave. Okay, odd symmetric. It is not even symmetric. It's odd symmetric. Acha, why about the even point? क्योंकि if you don't take about the even point, if you take any random point, you may be feeling अरे symmetry तो है, but is it symmetric? If you take any random point, you may be looking at sir, right side देखिए इस तरीके से जा रहा है, left is going this way, so this is even symmetric. Not at all, dear. Why it is not at all? Because the durations are unequal. Left side more, right side less. So how they are mirror image of each other? Not possible, na? Okay, not possible. Mirror image means even the duration, right में जितना है, left में भी उतना. Shape match, duration also match. Okay, so definitely this cannot, by any shifting, this cannot become even. By any shifting, this cannot become even. Are you getting it? Okay, so C will not be counted here. So the answer for this part is the combined answer. If I write down A, B, E, F. Now be ready. This can really become a good MSQ question. This can really become a good MSQ question. ठीक है ना? ये एक बहुत ही बढ़िया MSQ question बन सकता है. Okay, done है? Next question. Next, what is fourth point? Integral x omega d omega 0. Which of the signals satisfy integral x omega d omega? What is the property integral x omega d omega? So all important and interesting properties are getting covered today. Along with the first question, we saw lots of Fourier also, but properties भी cover हो रही है. Integral x omega d omega. अभी next question भी आएगा. That is also very good. Okay, so dear, integral x omega d omega, that is area under Fourier transform, is given by the property 2 pi x 0. Okay, so you want it to be 0. That means you need to search a signal whose value x0 is 0, whose value at the origin is 0, whose value at the origin is 0, whose value at the origin is 0. और कोई भी odd symmetric signal उठा लो, origin पे हमेशा 0 होता है. Okay, so A, okay, even B origin पे 0, even C origin 0, even D origin 0. Okay, not this one, and even F, except E. All are the answers. Okay. Except E, all are the answers. Okay, so we have A, B, C, D, F, except E, except the E. ठीक है, yeah, बिल्कुल सही. Concepts important है, so you are able to handle all variety of question. Number 5. Okay, integral omega x omega d omega, omega multiply कर दिया है, omega multiply कर दिया है. Integral omega x omega d omega, have a look into this. Integral omega x omega d omega is 0. Acha, because it is 0, okay, let us multiply both the sides by j. So integral j omega x omega d omega, that will also be 0, na? Even if you multiply j on both the sides, okay, right side still remains to be 0. Now dear, integral x omega d omega is 2 pi x 0. Now think, whose Fourier transform is j omega x omega? Whose Fourier transform is j omega x omega? Okay, this is known as the Fourier transform of x dash t. Okay, so what should be the answer? Okay, so that means the answer should be like x0, answer should be 2 pi x dash 0. Okay, now 2 pi x dash 0 should be 0. 2 pi x dash 0 will be 0 if x dash 0 is 0. So you want a signal whose derivative at the origin is 0, whose derivative at the origin is 0, whose derivative at the origin is 0. Okay, have a look into it. Dekho, now look into the part passing through origin. It's a straight line. Several times I told you, when you differentiate a straight line, y equal to mx plus c, whatever may be the slope, whatever may be the y-intercept, when you differentiate mx plus c, okay, dy by dx is always constant, that is equal to m. Matlab it's going to be a flat curve. It's going to be a flat curve. Okay, it's going to be a flat curve. Okay, so when you differentiate this portion, there will be some flat curve that is equal to slope. Don't calculate slope, okay? But it is not 0 actually. It is not 0. Second part pe aa jate, again there is a ramp. Okay, so when you differentiate, you get a flat line. Okay, that is not equal to 0. Okay, derivative dekhna hai. Now here the signal itself is absent at 0. So the differentiation of impulse, doublet. Okay, that is a doublet, but that will also be at 1. So yahan pe zarur 0 hoga. Okay, look into this. Here also signal for t less than 2 is 0. So derivative will be 0. Derivative will be 0. Okay. Now, isko dhyan denge. E power minus t square by 2. What is the differentiation of e power x? Is e power x. But by chain rule, so e power minus t square by 2 is multiplied by minus 2t by 2. And if you put t0 directly, if you put t0, answer is 0. ठीक है, यहाँ आप slope देख सकते हैं again, यहाँ पे slope of tangent. ठीक है, by x dash means what? The derivative means slope of tangent. Okay, so here the slope, the tangent is parallel to x-axis. A line parallel to x-axis has 0 slope. ठीक है, similarly here also if you check the slope, okay, the tangent here at origin is itself x-axis, means 0 slope. Okay, so what are the values satisfying 0? Okay, B and C, E and F. Okay, ठीक है, done है. Okay, so B and C, E and F. Here it is going to be what? B, C, E, F. Note down your answers here. ठीक है, B, C, E, F. Correct? All right. Now one more is left. X omega is periodic. Fourier transform is periodic. Okay, it is only possible if the signal xt is periodic in continuous time domain. Discrete time mein to you will learn. Okay, next class will be DTFT. You will learn that DTFT is always periodic. But continuous time Fourier transform of a signal can only be periodic if the signal is periodic. अच्छा, वो भी हमेशा true नहीं है. Vice versa is not true. If xt is periodic, x omega not always periodic. But if x omega is periodic, xt should always be periodic. Then only it is possible. Okay, so that is only possible with, what is a periodic waveform? That is only possible with option number A. Okay, that is only possible with waveform A. With waveform A. Okay, with waveform A. Okay. So let me write down, don't be misguided. So point number 6 में लिखूंगा x omega is periodic. So xt must be periodic, but reverse of this is not necessarily true. जरूरी नहीं है कि इसका उल्टा सही हो. अगर xt periodic है तो उसका Fourier transform हमेशा periodic होगा. नहीं, that depends on ck. What is the Fourier transform of periodic signal? अभी देखा था 2 pi summation ck delta omega minus k omega naught. That depends on the ck. We generally can't say the Fourier transform will be periodic. ठीक है ना? ठीक है, done है. Okay, so reverse not necessarily true. एकदम clarify कर दिया है. Now next, again a good property question coming up. But before we go to that, let me give you a quick reminder that for GATE 2024 All India Open Mock Test, okay, MMCs, the Mega Mock Challenges are already live now from 14th of October. First MMC started. Okay, so first of few these MMCs are, mixed subject test. Okay, like the first MMC is containing the syllabus of aptitude, maths and control system. Then next. After some time, you will get full complete syllabus exams. Okay, see, these are open mock tests, open for all, free. Okay, you can participate and compete and see your performance, see your rank. Okay, the first MMC will be up to 20th October live. The result will be declared on 21st. Okay, the result will be declared on 21st. Okay, so number one benefit, you get to practice and you get to compete among the students. But number two benefit also, that in the result, if your performance is good seen in the result, you can also avail huge discounts on the BYJU'S test series. Okay, so these are open tests. You can also enroll to the complete test series of the BYJU'S. Okay? Chalo, next question. Okay, let x omega denote the Fourier transform of the signal xt depicted in this given figure. Okay, that is 4.25. Okay, find angle x omega, x of j0, integral x omega d omega, integral x omega 2 sin omega, etc. Okay, some of them will be good also. Okay. Note, you should perform all these calculations without, ये बहुत important point है, even if they don't mention, the intent of the question is same. They are not asking you to calculate Fourier transform of xt, otherwise it's going to be a tedious activity. Okay, you should perform all these calculations without explicitly evaluating x omega. For conventional point of view, they have written, but forget the conventional nature. We are solving for GATE, but still for GATE also we will solve it property based. If you try to calculate x omega and then solve, you are lost. It will take a lot of time. तो इसलिए डायरेक्ट करते हैं. Now how to calculate angle of x omega? Okay, xt, does xt show any sort of symmetry? Does xt show any sort of symmetry? Think. Does it show any sort of symmetry? What if the origin was 1 unit right? What if the origin, y-axis actually was 1 unit right? Suppose if I shift the y-axis 1 unit right, then it is even symmetric, left and right same. Okay, so what is the meaning? I mean, let's not shift the y-axis. Actually, when you left shift the signal, it will be even symmetric. Okay, so what is very clearly seen here is option number A पे आते हैं. When you left shift the signal x of t plus 1, okay, that will become real. So anyways, it is a real signal only. Okay, all the values are real, 2 say 1, then 1 2 etc. Okay, but at the same time it will show even symmetry if you shift it by 1. Okay, if you shift it by 1. Acha. So what is the Fourier transform of xt plus 1? What is the Fourier transform for xt plus 1? It is given by x omega e की power j omega. It is given by the x omega e की power j omega. Clear? Okay. By the time shift property. So if a signal is real and even, Fourier transform is also real and even. Okay, Fourier transform is real. इसका ये मतलब है, because it is a real quantity, let us take the total phase of it, and that should be 0. Now what is the phase when two complex numbers are multiplied? See, there will be a phase. Okay, I want to calculate the phase of x omega e power j omega. Okay, and when two complex numbers are multiplied, the phase are added. So angle of x omega plus e power j theta ka phase theta. E power j theta is a phase term having the phase theta. So angle x omega plus omega is 0. You get your answer. Angle x omega is minus omega. That is the answer for the first part. What is the phase of x omega? That is minus omega. Only phase without calculating the Fourier transform, just by property and the logics. But again, for this concept and practice should be really good to handle all these questions. Next, x0. Ye simple hai. Okay, B part is simple. What is the x0? That is a basic property. x0. It is nothing but known as the area of xt. x0. Integral xt dt. Integral minus infinity से infinity. Integral minus infinity से infinity xt dt. Integral minus infinity से infinity xt dt. Okay, that is the area of xt. Done. That is capital x0. So what is the area of this signal? भाई बता दीजिए इसका area कितना हुआ? Okay, so rather than calculating the area of rect and then trapezium and etc., what I will do is, okay, assume this is flat. Assume it to be flat. So what is the area? Then it is a rectangle figure, height 2 and base equal to minus 1 say 3 4. Okay, base into height into base. Okay, minus. Okay, no, it's not flat. Okay, so subtract the area of this cavity. Ye area hata dijiye. Okay, so that is half into the base. Okay, 0 se leke to base 2 into the height, that is 1. So 2 se 2 cancel. 8 minus 1, the area is 7. Clear? The area of it is 7. Correct, Ananta? Correct, Sathi? Okay, the area of it is 7. So this one B wala simple tha. Okay, so the area, and that is equal to 7. Okay, part number C. What is the part number C? Integral x omega d omega. Like previous question, already we used this property. Integral x omega d omega, and that is given by the formula 2 pi x0. This comes by the inverse Fourier transform actually. Okay, 2 pi x0. 2 pi, the value of the signal at origin. The value of the signal at origin, clearly seen, it is 2 units. It is 2 units, so this is 2 pi into 2, so this answer is equal to the 4 pi. This answer is 4 pi. Okay, D. Okay, integral. D is actually good. Integral x omega 2 sin omega by omega e power j2 omega d omega. D पे थोड़ा सा focus करेंगे. Okay, let's learn the D part now. Okay, integral x omega 2 sin omega by omega e power j2 omega d omega from minus infinity to infinity. Okay, let's focus this. This one is a good part. Okay, what I will do is, okay, let this signal be something. Okay, let this signal be, suppose some Fourier transform y omega. That is 2 sin omega by omega e power j2 omega, or I can call it as 2 sampling omega, sin theta by theta sampling, 2 sampling omega e power j2 omega. Okay, yes, okay. So this integration is like integral x omega y omega d omega. Okay, now let's say x omega y omega, the product is z omega. Let's say their product is z omega. Okay, their product is z omega. So I have defined the product z omega as x of omega y of omega. Okay, so there is a multiplication in frequency, and multiplication in frequency occurs when there is convolution in time. Correct, Shubha? There is going to be convolution of xt with yt. There is going to be convolution of xt with yt. Okay, so what is xt? The convolution formula, if you expand, that is going to be integral x tau ht minus tau. Integral x tau ht minus tau from minus infinity say infinity. But what you actually need is, let's go back. Several properties link here. Integral z omega d omega. Okay, like integral x omega d omega is 2 pi x0, na? Similarly, we can use the property. Okay, so this one should be equal to 2 pi z0. 2 pi z0. Okay, 2 pi z0. So we actually don't need to convolute it completely. We only need z0. And z0, okay, if you put t equal to 0, okay, you will get integral of x tau h of minus tau. H of minus tau d tau. Okay, ये h नहीं है, sorry, ये y है. That's all. Okay, integral x tau y of t minus tau. Okay, so here it is x tau y of minus tau d tau. So what you need is y minus tau, only y minus tau. Okay, multiplied by x tau, and then द इंटीग्रेशन माइनस इन्फिनिटी से इन्फिनिटी. अब देखो व्हाट इज वाई टी, ये समझना पड़ेगा यहाँ से. वाई ओमेगा इज 2 सैम्पलिंग ओमेगा ई पावर j2 ओमेगा, हुज फोरियर ट्रांसफॉर्म इज 2 सैम्पलिंग ओमेगा. टी सैम्पलिंग ओमेगा टी बाई टू है, रेक टी बाई टी है, रेक टी बाई टू, करेक्ट. बट नाउ देर इज अ एक्सपोनेंशियल टर्म, डायरेक्ट लिखूंगा मैं, there is an exponential term in the frequency domain. That means there is time shifting. So this is, without the exponential term it is rect t by 2. Okay, with the exponential term it is 2 units of shifting, rect t plus 2, e power plus j2 omega, so rect t plus 2. Okay, hope you are able to relate this, because in the very beginning we have solved lots of questions on this sampling rect. So it is rect t plus 2 by 2. Okay, rect t plus t by 2. So what is, first of all, let me quickly sketch what actually y tau means. Okay, as a function of tau, नाम में कुछ नहीं रखा है, whether it is yt or y tau. So let me sketch y tau. Okay, rect t by 2. That means total base of the rectangle is 2, but it is left shifted, t plus 2. The rectangle is normally centered at origin, but it is 2 units left shifted. Okay, so its center should be minus 2, and the total width is 2. Total width is 2 means minus 3 से minus 1. And this is the center, that is minus 2. Clear? That is y tau. So what I need is y minus tau. What I need is y minus tau. Y minus tau means mirror image of this. Okay dear, to take the mirror image, it will become 1, 2, 3. It will become from 1, 2, 3. Take the mirror image, it is now becoming from the 1 to the 3. Done it? Okay, cool. It is the 1, 2, 3. Okay, so now we need to multiply it with x tau. Okay, so from 1 to 3, okay, acha, देखो, from 1 to 3 you have a rectangle of amplitude 1. 1 into anything, 1 into x tau will be 1. 1 into x tau will be 1. So x tau का ये वाला portion, that is from 1 to 3, that will be copied. That will be copied. Okay, so this one was a good question actually, to be honest. This one was a good question. So now let me multiply. Okay, let me have the multiplication x tau y minus tau. So only the result will be there from 1 to 3, and the rectangle and the x tau portion will be actually copied. ठीक है, done. Now integral of the x tau y minus tau, integral of any function is area under the function. Okay, so this is equal to area of this figure. So what should be the area of this figure? Again मैं पूरा rectangle का ही निकाल लूँ पहले. height 2 and base 2, 2 to the 4 minus half base height. So ये आंसर आ गया 4 minus 1 by 2, that will be 3.5, that is 7 by 2. ये हो गया 7 by 2. Okay, we'll go and put the answer there. So this is 2 pi 7 by 2. So the answer for the question is 7 pi. This one was beautiful question. This one was a beautiful question. It takes effort. Okay, let's learn the beauty of the question. Let's learn property. Let's evolve in concepts. That's what the idea is. अभी नहीं आया कोई problem नहीं. But are you able to learn something new? Are you able to learn concepts? That is the intent here of solving the standard book question. Okay, intent of solving the standard book questions. Chalo, perfect. Okay, so let's move ahead to the next case. Next is what? Integral x omega square d omega, Parseval's theorem. Okay, the e part, integral mod x omega square d omega. Okay, इसका केवल hint लिख देता हूं मैं आपको. Okay, the e part, integral mod x omega square d omega from minus infinity to infinity. If you apply the Parseval's, that will be 2 pi, okay, energy of the signal in time domain, that is integral mod xt square dt, integral minus infinity to infinity mod xt square dt multiplied by 2 pi, multiplied by the 2 pi, 2 pi integral minus infinity to infinity mod xt square dt, mod xt square dt. Done, ji? That's what it is. Okay, ji. Okay, so guys, complete this as a homework. Okay, how to calculate the energy in time domain and all those things, all those stuff you must be knowing. So please complete that in as the homework. Please complete that as the homework. Let's come to the F part. Sketch the inverse Fourier transform of real part of x omega. अच्छा, whose Fourier transform is real part of x omega? आते हैं F part पे. Whose Fourier transform is real part of x omega? See guys, please note that if xt is having the Fourier transform x, has the Fourier transform part of x omega. Even part of xt has the Fourier transform, real part of x omega. Odd part of xt will have the Fourier transform that is known as j imaginary part of x omega. So let's use these property. So what is the inverse Fourier transform of real part of x omega? Even part of xt. Even part of xt. तो अब देखो even part of xt निकाल लेंगे. Xt is given to me. I want to calculate what? I want to calculate the even part of xt. Right. So my answer is even part of xt. Acha, what is the formula for even part of xt? That is given by x of t plus x of minus t divide by 2. Chalo, let me complete this. It is a good sketching activity. Let me also sketch this for you and complete the answer. So this is xt first of all. Let me draw the xt that is given to us. This is the xt given to me. This is the xt. Now I want to add the xt, with its mirror image. I want to add the xt with its mirror image. So x of minus t. What will be x of minus t? चलिए इसको ले लेते हैं. X of minus t taking its mirror image. ठीक है. Now I want to add and then divide by 2. I want to add and then divide by 2. So when you add this quickly करते जा रहा हूँ. You let me know if you have any doubts. Quickly. So minus 3 to minus 1. First focus here. Minus 3 to minus 1. This part is 0. 0 plus x will be x. So replicate this part. Between the minus 3 से minus 1, replicate this part. अच्छा, also between the 1 to 3, this is 0, that one is something. Suppose x. X plus 0 will be x. So even from 1 to 3, you don't have to worry. You have to replicate the signal. You have to replicate this signal. Suppose this is x. X plus 0 will be x. And all the amplitudes will be divided by 2. ये भी ध्यान रखना. So this was how much? 0 plus 2. तो ये 1 हो जाएगा actually. And this will become 1 by 2. ये बाद में करेंगे. ठीक है. That magnitudes let me write down later. Magnitudes let me write down after. Next. अब next देखेंगे यहाँ पे. What is the next? Between, the interesting point is between minus 1 to 0. पहले ये देखते हैं. Minus 1 to 0, this is constant 2. Minus 1 to 0, this is a straight line added with constant 2. What is the role of addition of constant? Amplitude shifting, raising the waveform. The amplitude will be raised by 2. The amplitude will be raised by 2. So iska ye jo straight line hai, this suddenly it will be raised, by amplitude, and then it will follow the same nature. Similarly, come to 0 to 1. 0 to 1, this is a decreasing line. There's a straight line, whether increasing, decreasing. It's a straight line that is going to be added with 2. So again, that will be raised. Raised here, something like this. Yahin se rahega. So that is the raised decreasing line. Ye wala portion. This portion is appearing here. And then suddenly it takes the dip. And this is joined here. This is the correct answer. This is the correct answer. Now let me write down the amplitudes. So this was 0 and then this was 2. So this will be 1. This will be 1. So definitely this reaches 0.5. So now if this was 0.5, ध्यान देना. If this was 0.5, left side पे देखते हैं. So directly I do plus 2 here. Divided by plus 1 करेंगे इस पे. So this will be 1.5 and it will go to the 2.5. ये peak value कितना हुआ? That is 2 plus 2. ठीक है, ये 1.5 है and it will go to the 2. It will go to the 2. It will go to the 2. Perfect. These are the amplitude levels. These should be the amplitude levels. Okay. Right. If there is two ramps of different slopes, then the answer will still be a ramp, but their slopes are added. Here it is a slope plus amplitude plus a constant. But if two ramps are there, like the first class also I have taught you. Okay. Whenever two ramp signals are added, their slopes will be added. Chapter 4 all-rounder, continuous time Fourier transform. Okay. Chalo. Done hai this part. Next question then ready for you. Okay. Suppose that gt is equal to xt cos t. So today we have already seen some questions on modulation. This is also on modulation. Okay. Suppose gt is equal to xt cos t and the Fourier transform of gt is given to you. The Fourier transform of gt is given to you. Gj omega 1 for mod omega less than equal to 2. Otherwise it is 0. So let me draw this waveform. Okay. Yes, simple. It's a conceptual but simple question. Okay. Let us draw this first of all. Okay. Let us draw what? Let us draw the g omega. So I'm trying to draw the g omega which is equal to 1 for mod omega less than equal to 2. For the mod omega less than equal to 2. It is equal to 1 for the mod of omega less than equal to 2. ये 2 है, ये minus 2 है, this is equal to 1. This is g omega. Okay, 1 for mod omega less than 2. Okay, now g omega is the Fourier transform of gt. Okay, okay. gt is xt cos t. Okay, so what is g omega? As per the modulation again, as per the modulation, it should be x of omega, okay, minus 1 plus x of omega plus 1 shifted to higher frequencies and amplitude divided by 2. So the waveform that is given to you, dear, the waveform g omega, it is a combination of x omega minus 1 plus x omega plus 1. Okay, shifted to higher frequency, but the only frequency content is up to the 2. The only frequency content is up to the 2. Okay, and there is no break in between. That simply means, okay, there is no break. Otherwise, 1 x omega minus 1 right side पे दिखता है, right shifted, x omega plus 1 left side पे दिखता है. So I can say that whatever is the left part, okay, is x omega plus 1, whatever is the right part is x omega minus 1. Okay, so what I can say that separating it out, okay, this portion on the right, okay, this portion can be x omega minus 1 and this portion of the left can be x omega plus 1. Clear? Okay, and then after dividing by 2, the amplitude is 1. Okay, so say this is half x omega minus 1, this is half x omega plus 1. So actual x omega amplitude should be 2 actually. Amplitude should be 2. So by this knowledge, let me draw what is the x omega. So your xt is also obtained. Okay, looks a simple but a pure conceptual question. Understanding of the waveforms is important here. Okay, so what is x omega? Now this is x omega minus 1. Okay, that is right shifted. Okay, and centered at 1. So x omega minus 1, right shifted version is at 1. So when you bring the original signal, when you want to bring the original signal, वो 0 पे आ जाएगा. Okay, so that is minus 1 से 1. That is minus 1 से 1. Okay, 0 should 2 की जगह minus 1 से 1 and amplitude should be 2. So what is this x omega? Okay, it is 2 rect of omega by 2. 2 rect omega by 2. Okay, dear, what is the x omega? It is 2 rect of omega by 2a. Omega by 2a. a का वैल्यू 1 है ना, तो यहाँ पे भी हमें चाहिए होगा pi by a. Okay, I want pi by 1 here. Okay, so 2 by pi into pi by 1. Pi से divide multiply किया. Rect of omega by 2a. Pi by a rect omega by 2a. Whose Fourier transform? Sampling Fourier transform. So now take the inverse Fourier transform xt. This 2 by pi remains to be constant. So answer is 2 by pi into sampling at. A का value 1 है. 2 by pi sampling t, or you can also write this as 2 sin t is divided by pi t. Sampling t sin t by t. तो 2 sin t upon pi t. आ गया answer xt का. Okay. So now dear, if xt is done, second part is homework for you. Specify the Fourier transform x1 j omega of a signal, that is x1 t into cos 2t. Okay, such that gt is equal to x1 t cos 2t. Okay, so now you have to think about gt again. Okay, you have to think about gt. Similar part, okay, with gt, x1 t cos 2t. Okay, rather than xt cos t, it is x1 t cos 2t. Now think about this. Okay, if you have got the first one, second bhi aa jana chahiye. If you have got hold of the first one. Okay, you have to think about a signal like you thought about xt. This is signal, but that is right shifted and left shifted by the frequency, that is 2 by 3. Right shifted and left shifted by the frequency, that is 2 by 3. Okay, not 1 but 2 by 3. Think about this. Aa jayega. Okay, aa jayega. So B part will be a homework. Okay, because modulation has several questions today we have discussed on the modulation. Several questions today we have discussed on the modulation, isn't it? Chalo, done hai. Let's go to the next one then. Also guys, before I go to the next one, already I updated you that the MMC is live, and other than MMC is on the Byju's app. You can utilize several other practice sessions, practice quizzes, make a habit daily attending some of the other quiz, so that you keep on practicing and competing with your fellow friends. Check yourself in the leaderboard. So you can download the Byju's exam prep app from the Google Play Store, or already there is a link in the description of the video. You can directly join using that particular link. Okay. The output yt of a causal LTI system is related to the input xt by the equation given to you. A differential equation is given. Okay, dy by dt plus 10 yt is integral x tau zt minus tau d tau minus xt, where zt is e power minus t ut plus 3 delta t. So dear, what is this? Integral x tau zt minus tau. That is nothing but xt convolution zt. That is nothing but xt convolution zt. Okay. So when you want to convert it, okay, apply the Fourier transform property. D by dt of yt, j omega, okay, j omega y omega. Fourier transform of 10 yt, okay, 10 y omega. Now what is the Fourier transform of xt convolution zt? Convolution in time will be multiplied in frequency, x omega z omega minus xt. So xt Fourier transform will be x omega. Okay. Now I want to calculate the frequency response. That is definitely the ratio of output to the input frequency response. Okay, so ये कितना हो गया? I can have j omega plus 10 y omega separated, common ले लिया, y omega constant, j omega plus 10 is equal to, in the right side let me take the x omega constant, and now you will have z omega minus 1. What is z omega? Dear, zt is given na? E power minus t ut. What is the Fourier transform? E power minus t ut, 1 upon 1 plus j omega, 1 upon a plus j omega, 3 delta t, 3 delta t, 3, and then minus 1. Okay, so okay, y omega whole multiplied by 10 plus j omega is equal to x omega. Let me simplify. So what I'm going to get, 3 minus 1 2 हो जाएगा, then 1 plus 2, that will be 3 plus 2 j omega. तो 3 plus 2 j omega is divided by 1 plus j omega. एक बार check कर लेना, but I think that is correct. That should be correct. Okay, so what is the frequency response? Y omega by x omega. That is known as the h omega, and that is actually turning out to be how much? 3 plus j 2 omega divided by 1 plus j omega is multiplied by 10 plus j omega. That is the frequency response. Done. What is the impulse response? What is the impulse response? अब इसको break कर दो partial fraction में, a upon 1 plus j omega plus b upon 10 plus j omega. Okay, what is the value of a and b multiplying throughout by 1 plus j omega, 10 plus j omega? तो 3 plus j2 omega quickly करते जाते हैं, is a into 10 plus j omega plus b into 1 plus j omega, right? So let's try some values. So if you put down j omega ka value minus 1, okay, if you put down j omega ka value minus 1, so you will get 3 j omega minus 1. So 3 minus 2 is equal to a wala part 0, j omega minus 1 rakha maine. Okay, so it will be a into 9 and b part will be 0. So a value will be 1 by 9. Okay, a value will be 1 by 9, and then if you put j omega equal to minus 10, okay, so minus 10, so 3 minus 20, okay, will be, now a part will be 0, and then you will get b, okay, into minus 9, 1 minus 10. Okay, so b value will be minus 17 by minus 9, so 17 by 9. That is known as what? 17 by 9. Okay, so what is the h omega? Breaking it into partial fraction, 1/9 को कॉमन रख दें, 1/9 कॉमन, एंड देन a में 1 आ जाएगा, b में 17 आ जाएगा, 1/1 प्लस j ओमेगा, ओके, प्लस b में आ जाएगा 17/10 plus j omega. Let me be really confirm here. Okay, so we have 10 plus 17, 27, and then plus 18 j omega. Okay, so 27/9 3. Okay, perfect है. 18/9 2 j omega. Correct है. That is the correct partial fraction. Okay, so what is the impulse response? Okay, what is frequency response? Frequency response is the Fourier transform of impulse response. तो impulse response कितना आ गया? 1/9 e power minus t. Okay, and ये हो जाएगा 17 e power minus 10t. Both of them multiplied by ut. Okay, 1/a plus j omega. तो e power minus 80 ut. That is the impulse response of the system. Done है? So this part is the impulse response, and this part is the frequency response of the system. Okay. The impulse response of the system makes the Fourier transform pair with the frequency response. Frequency response is the ratio of output to the input Fourier transform. Okay. चलो. Of course, यहाँ पे mention नहीं है, but if you go try and check, the system is going to be stable. Okay, the frequency response analysis, okay, is valid for stable systems only. Okay, the frequency response analysis is applicable for stable systems only. Fourier transform can be applied only for stable system. Okay, so this has to be a stable system. ठीक है, done है. चलो, done है, cool. Okay, so this is also one application based question on the Fourier transform. Okay, so yeah, time is 10:35. We are nearing 10:40. That's it from my side. Okay, from my side.
Didn't catch that.
Stability though we'll learn, you know, stability is actually a concern, you know, you more talk about stability in the Laplace transform case, or better and better, you know, the methods of stability you learn in the control system. Shubha. ठीक है, that's it guys. So GATE crash courses for 2024 live on the Byju's exam prep. Okay, complete syllabus coverage through fast track theory revision and the detailed question practice, live classes, recorded lecture, study material, mock test, practice quizzes, everything that you need for your preparation will be there. You can contact 9241333666 for any queries, and these are available for all branches. That's it guys. So now next session, okay, let me tell you, we are gonna meet next, okay, Wednesday. Okay, as you know, we are running it alternate the next Wednesday. Time remains to be same, unchanged, and next class DT FT, discrete time Fourier transform. Chalo, very good, you reminded Ananta. Password. So you get the PDF in my Telegram group with the password protection. The password is stable, randomly drafted password, and that is going to be stable, stable. Okay, the password is going to be stable for the PDF. You can access the PDF through the password. So all questions with the solutions that we have discussed will be there. Chalo ji, that's it. Bye bye. Good night. Stay safe. Take care. See you Wednesday 9 PM.